What about a height?
The height? We don't care about the height right now. All right, so this width is the real house. That's what I want you to understand.
What dimension of the
This is the real house, and we are having this on paper. All right, Miss Morgan, do you have your book? All right, let's take that out, please. Sean, can you please join us? Did you see my response to your email? Okay. All right, let's put the backpacks down. Backpacks down. Computers need to be away. Heads need to be up. Isaiah, this is for you. Yes, take a picture. Yes.
Thank you.
All right. Yes.
So yesterday I went on Fiverr.
Okay, so people listen up. Because everybody keeps sending me this. When I say homework 3-2 is due on Monday, that means on Monday night, I will go through on Canvas and it will be graded. If it is missing that Monday night, then it will stay missing until I get back to it and it gets graded. Okay? It does not automatically, I don't think, take off when after you have submitted it until I look at it. That's as I understand it. Do you guys know if that's true? Yes. So Monday night I did that. I have not looked at it since. So if you did it yesterday in the afternoon, it is still going to be missing. Okay? Until I look at it and say, okay, you have done it. I can't change that. Okay? And I'm not going to do it necessarily every day. If you know you've done it, you have to tell your parents it's done. Okay? I'm waiting on Miss Stevie to take a look at it. All right. This says, what are the dimensions of the drawing? So this is the paper, on paper, what we are looking at. Now, you do not have any dimensions here. Okay? And I don't know. I should have probably checked in with Bieschke because what I have here in my book is slightly different. But this says the dimensions of the drawing are a length. The length is 2.875 inches long. Okay, this is the drawing on paper. The drawing on paper. Okay? The width on paper is also 3.3125 inches in length. Now that I'm thinking about it, she probably wanted you guys to actually measure it. But I just busted that. So I'm sorry. I took that opportunity away from you.
Is it the same thing as width?
No. The length on paper is 2.875 inches. The width is 3.3125 inches. The width of the real house is 600 inches in length, in long. Don't say length. Now, this says, what is the depth of the house? Depth is not really the right word here. What word do you think we're looking for? Yeah, we're looking for the length. What is the length of the house? Okay. What is the length of the house? So how would I set this up?
Fraction.
Okay, what do you mean by fraction? Tell me more.
So when we're talking about inches, it's like inches per foot or like or something like that.
Okay.
Height, we're talking about measuring, so you gotta like cancel like measurements.
Right. You are correct. And there's a way to kind of do that, and there's also a way to do this as setting it up as proportions. So what I know is that the width of the real house is 600 inches. Okay, I'm going to start with that. So the real house is 600 inches in length. Okay, this is the length. On paper, my drawing is, for its length, 2.875 inches. This is on paper. Okay? They should be equivalent amounts. They are equivalent amounts. All right? What we want to find is, did I mess that up already? I did, didn't I?
Real length.
Because it's not the length, this is the width.
Yeah,
You think I've taken some cold medicine? I haven't.
yeah, it's not
I haven't. Maybe I should. I am so sorry. This is the width, and the width over here is 3.3125. So you're going to have to get your erasers out. 3.3125. Okay? That's why you don't just blindly follow your teachers. We are human. We do make mistakes. Okay? Nobody caught me on that, or maybe if you did, you didn't say anything. You should say something. All right? All right, so the real width is 600 inches. The on-paper width is 3.3125 inches. The real length is how much?
We don't know.
We don't know. How do I represent a we don't know?
X.
X, a variable, a question mark, any of those. But since we're talking about math, probably our favorite variable X, okay? So this is the real length, and if I am trying, length, yes, length, I want to find, well, there's a couple different ways we can do this. I want to find what this is to the actual length on paper. What is my length on paper? 2.875 inches. And this is on paper. Now, does that make sense to you? I have the real width compared to the actual width on paper. I have the length that I'm looking for in real life compared to the actual length on paper. All right? And there should be a scale that I can use, like 1 inch is equal to something, okay? So this is called a proportion. This is called a proportion when you have one ratio set equal to another one. This is called a proportion. Okay? Or when you have one set of fractions equal to the other. You have had these in your past. I know you have. Does anyone recall how to solve this proportion? And we've had this before when we had solving for an equations. If I was trying to look for x, there's a couple different ways you could do that. What's happening to x right now? All right, guys, let's stop that. What's happening to x right now? Is it alone?
Wait, no. Oh, no, we gotta.
Sean, head up here, please. Javion, up here, please. What is happening to x? It's being divided. So how do I undo that division? We could multiply. What would I multiply by? No, not 600.
No, I said bottom.
The bottom, since this is what it's being divided by, to undo that, you would multiply by 2.875. So over here on the other side, you would multiply by 2.875. These would cancel out, and you have x equals, we have 2.875 times the 600, because that is in the numerator, divided by 3.3125. Gabe, let's make good choices.
Wait, shouldn't it be 2.875 with x?
No, we're solving for x. So when you multiply, you guys have the calculators. 2.875 times 600, divide by 3.3125. What do we get for x? Isaiah?
550.754.
550.754. Anybody else get that? 520. Check your numbers again. You might have put in something a little wonky. Oh, you said 520.
That's not what I heard.
That's not what I heard either, but I had hearing problems with my cold. 520 point. What was it again? 754. And what is this in units? Inches. And this is for the drawing, or this is for the real house? The house. What is the length of the house? So this is the length of the house. Okay? This is the length of the house. All right? So does everybody see how I set that up? I set up real width to width on paper, and that's equal to the real length, which was x, divided by the length on paper. Another way you could have done this, okay, is to cross multiply, and you would get the same thing. You would say 3.3125 times x equals, this is if you cross multiply, okay, you would say 3.3125 times x equals 600 times 2.875. If you cross multiply, you would divide by 3.3125, and you get the same exact thing. So again, this is the greatness of math, and this is the angst of math, because there are so many different ways to do it. It ends up being the same thing, though, if you cross multiply. Whatever the case, we know that our length of our house is 520.754 inches. Okay? Does that make sense if the width on paper is slightly bigger than my length on paper? Does it make sense that the width in real life would be slightly bigger than my length in real life? Does that make sense? Yes, it does. So, use some common sense there. Make sure you've got an answer that makes sense. All right, now let's go to the next question. It says, what is the scale of this drawing to the house? What is the scale of this drawing? Well, when you are looking about a scale or looking for a scale, you want to take it to 1 inch or 1 unit. Okay? We want to take this to 1 inch or 1 unit. So I'm going to go with what they gave me, because maybe, just maybe, we made a mistake when we found the length. But the width of the house is 600 inches. And the width I told you was 3.3125 inches. Okay? So I'm going to take my width of the actual house, which was 600 inches, and I am going to divide that by the width on paper, which I think was 3.3125? 3.3125. Okay? Because I am trying to figure out what is, and this is in inches too, on paper, I'm trying to figure out what it is to be 1 inch. All right? So, you could either cross multiply, or you could, as you look over here, if you're solving for x, you're dividing by 1, multiply by 1. Multiplying by 1 is going to get you the same answer. So take 600 divided by 3.3125.
181.
So that means, do you want to just put it here? Yeah, you can take your phone back. Thank you. I'll make sure she gets those. So when you divide, x is, one more time?
181.132.
Okay, we'll say 181.132 inches. So that means 1 inch on paper is this many inches in real life. That is your scale. Sometimes they will show a scale like this. They will say 1 colon, and if I round it, we could just say 181. So they're saying 1 unit or 1 inch on paper is 181 in real life. This is a scale. Okay? This is our scale. So would the scale be the same for my length too? Would the scale be the same? Would 1 inch be 181 inches in real life? What do you think? Would the scale be the same for the width as it is for the length? Actually, it is. Yeah, because when you have a drawing or a picture or a map, you know, you have that scale in the legend area. That scale is the same for all distances, whether it's a width or whether it's a length, right? So this last question says, what is the area of the house? Now, as you look at this house, what basic shape does it take?
Square.
Well, are both sides exactly the same, though?
No, that would be like.
You always say square.
Wait, I see one is like the trapezoid.
Well, yeah, but we're not going to get that picky. But what is the basic shape? Not a square. Somebody said it. Rectangle, yes. Yes, Miss Dee. Of course. Yes, so rectangle. How do you find the area of a rectangle? Length times width. Do we have the real length of the house? Don't we? I hope so. That was part of the problem. Do we have the real length of the house? Yes. Do we have the real width of the house? Yes. Can you multiply those together and tell me the area of that house? Yes. Then, after you do that, I want you to figure out, because your first answer will be in square inches, how would you find that answer in square feet? Now, we've done some of this before when we were doing some of those conversions. So, first of all, I want you to find the area of the house, length times width, in square inches or inches squared. Then you need to find it in feet squared. And I'm going to have you give me 10 good minutes of work. 10 good minutes of work to get those two things done on your own. Then we'll come together and see how you did. Okay? 10 minutes. So I'm going to pause. So, what did you multiply first to get square inches? What did you multiply? Gabe, what did you multiply? what did you multiply to get the square inches of the area of this house? So for this real house, you multiplied what? Say it again. Huh? Oh, wait, I'm talking to him. One more time. 2.87 what? So your real house is 2.87 inches in length? No, we want the house, the real house. Okay? Now, guys, this isn't terribly difficult, but you have to practice. You have to do the work. Okay? Colton, did you do this at all? No. I appreciate your honesty. Guys, if you didn't do it, just say no. I'm not going to yell and scream. Not today. Okay? Jemiah, yes. What did you multiply? 520.754 times the width of 600. Is she right? Or is that the numbers we should multiply? Yes. So when you multiplied those, did you get a final answer? And what did you get?
312,452.4.
Is there a decimal in there somewhere?
Yeah,
0.4? 312,452 and 4/10. And how would this be labeled? Because labels are really important. Inches squared, because we are talking about area. So we're talking about how many little square inches fit in here, right? How much time do I have? Ooh, 4 minutes. All right, this is my area. Now, how do I change that to feet squared? Multiply. This is inches squared. What am I going to multiply it by? What is my conversion, my unit conversion that I know about inches and feet? 12 inches is 1 foot. Which one's going to go on the bottom if I have inches on the top? Should go on the bottom, the 12 inches, and the 1 foot goes here. But the problem is this is only inches linear. What do I have to do to make that inches squared? Multiply, sort of. I need to square that amount also. So 12 squared is going to be 144 inches squared. If I square the bottom, I also have to square this. What is 1 squared? 1. And this becomes feet squared. Okay. So this is no longer here because I multiplied that out. Inches, it's going to cancel out. And if you take this and divide it by this, did anybody get that number? Say a little louder. 2,159, 69.8 feet. 08 feet. Okay. We're just going to say feet squared. Now, does that seem like an appropriate size of a house? Do you hear of houses being about 2,000 square feet?
Yes.
Yes. So, what to look for and be aware of is to be careful. If you know, if you know 1 foot is 12 inches, but you're talking about square inches, you need to square the top and the bottom. So keep working on homeworks 1 and 2. for this module 8. Okay. Yes, they said you were. Who was your partner?
Reese.
Who?
Reese.
Reese. Oh, she's not here today. Okay.
So I did the frog in the life because up here they were talking about the frogs. And
Uh-huh.
I did have time. I was going to draw some trees right here because this.
Oh, we don't need trees. That's okay.
So this
No.
is good.
Well, I don't know. Did you answer the question?
We should have.
Can a frog hop 20 times its body length? What would that be?
An average frog could. It says that trees, frogs, and leopards could jump 15 to 20 times their body length.
Okay. So, but did you show me? Okay. So how long is your frog? If it can jump 15 to 20 times, we're trying to figure out what is that length.
And the frog is about 2 to 4 inches.
Okay. 2 to 4. So what is that if it's 20 times its length? How would you find that? A frog can hop 20 times its body length. So if its body length is 2 inches, how would I find out how long it can jump?
You wouldn't measure. You would just test it. You could test it.
Well, we don't have any frogs to test. So they're telling you a frog can hop 20 times its body length. So if your frog is 2 inches long, how long can it hop?
2 inches.
No, that's the body length. It can hop 20 times
20
its
times.
body length.
So 40.
Right, but I don't see that on here at all.
Can I write it real quick?
Yeah.
Can I see that? Oh, that's not.
No, this is not a pencil.
So our frog can jump 40 times. No, 40. What? 40 inches because 20 times 2 is 40.
Yeah. But you see, that's what we were trying to figure out. How long would it be that it could jump then? If it can jump that.